on this circle of radius 0.5 around Q1, the electric field E1 due to charge Q1 is always going to be radial and always of the same magnitude, and the approximate magnitude we've got here. Actually, I think these E1 vectors should have been a little bit larger, so that they would at least be a little bit larger than this one, because of course at this point the field strength will be greater than it is at this point. However, let's accept that E1 might look something like this at each of these points. And there's another E1 drawn here. Now these are the electric field vectors at points of this circle. We've also sketched the E2 vectors at points of this circle. E2 always being directed toward the charge Q2. Now, at each of the points on this circle, there's an E1, but there's also an E2, a vector. For example, at this point, it's going to tend to pull the electric field this way. That is, there will be an electric field E2 in this direction toward Q2, and the actual field at this point is going to be the resultant of E1 with the E2 vector that we get here. Now the E2 vector at this point will not be as large as the E2 vector on this circle because we're further away from Q2. So it'll be at least slightly smaller, slightly less in magnitude. So the task I want you to do, I want you to pause the tape before we go on, and I want you to actually attempt to sketch what the E2 vector would be here and then the resultant at this point, and do the same at this point and the same at this point. Then, for each point on the circle around Q2, we want to sketch the E1 vector. Okay, we've got an E2 vector at this point, and it points back toward Q2, but there's also an E1 vector pointing away from charge Q1. That E1 vector won't be as long as this E1 vector because we're further away, and we want to estimate how much shorter that vector might actually be at this point, and then sketch the vector, the E1 vector at this point, and the resultant. So that we go around both of these circles sketching the resultant vector. Starting with the vector E2 on this circle, we sketch the E1 vector at each of these 3 points. Starting with the E1 vector at each of these points, we then add the E2 vector at each point. And then we find the resultant at each point. So pause and do that, and then we'll look at what the solution might be, at least a couple of points. Okay. Now here is one of the points that I indicated. The E1 vector is going to be straight away here. The E2 vector will be toward the charge here, and the E2 vector will be shorter than the E2 vectors we had in the previous picture. And the resultant will then be the diagonal of the parallelogram that we get from these two vectors. And it'll look something like this. So we see that E1 has been distorted by being lengthened slightly because these vectors are both have components in positive components in the direction away from the charge, but also pulled down toward Q2. So we can think of at this point the electric field is pushing a positive test charge away very strongly from the charge Q1, the 5 microcoulomb charge, and attracting it slightly toward Q2, the negative 2 microcoulomb charge. Actually significantly, but not nearly as much as this. So this vector has significant length, but not as much as this one. And that push in this direction and a pull in this direction result in a net force in this direction, or net electric field in this direction. Now at this point, the E1 vector, the vector repelling from the 5 microcoulomb charge, won't be quite as great as the E1 vector on this circle because we're slightly further away than we were on the circle. The E2 vector will just be the E2 vector that we had, and we're going to get a resultant like so. Now as we go around the circle, we should be able to sketch the E1 and E2 vectors at the other indicated points.